Hello, today we'll look into this problem. The question is determine where the function f of x, and f of x is given as x cubed minus 3x squared plus 1 is increasing or decreasing. Right? So we need to find the interval where the function f of x is increasing or decreasing, and secondly the question asks, moreover, use the first derivative test to locate the relative maxima and relative minima if any of f of x. So first of all, let's find the interval where the function is increasing and where it's decreasing. To find that, first of all, we need to find the critical points. To find the critical points, we need to first of all find the derivative of f of x. So the derivative of f of x is, utilizing the power rule here, we get 3x squared minus 6x. Then we set the derivative f prime of x to be equal to 0. So which simply means that 3x squared minus 6x is equal to 0. Let's try to solve for x. So 3x is common to both. So we have 3x into x minus 2 is equal to 0. Therefore 3x is equal to 0 or x minus 2 is equal to 0. So we get x is equal to 0, right, and x is equal to 2. So these are my critical points. X is equal to 0 and x is equal to 2. Then we draw a number line. So this is 0, so that is 2. Okay, that is 0 and that is 2. Now from here, okay, we need to find, right, whether this side is increasing, whether decreasing or increasing in that particular order. We'll have to find or vice versa. So we know that the derivative of a function at a particular point gives us the gradient. So if I find the derivative of a number less than 0 at a particular point, that will give me the gradient at that point, which will tell me what is the sign that side. So a number less than 0, let's say negative 1. So let's find what is f prime of negative 1 equal to. So that is equal to 3 into negative 1 squared minus 6 into negative 1. So that is equal to negative 1 squared is 1, so 3 times 1 is 3. Then minus 6 times minus 1 is 6, so that is 9. And 9 is greater than 0, which means this part is positive, which basically means that has a positive gradient. Next, between 0 and 2, let's say f prime of 1. So we'll have 3 into 1 squared minus 6 into 1. So we get 3 minus 6, which is equal to minus 3, and minus 3 is less than 0, which means the gradient between 0 to 2 is negative. Then a number greater than 2. Let's find f prime of 3. So we'll have 3 into 3 squared minus 6 into 3. Now 3 squared is 9, 9 times 3 is 27, minus 6 times 3 is 18. So 27 minus 18 is 9, and 9 is greater than 0, which means that the gradient over here is again positive. Okay. So now looking at the interval where the function is increasing and the interval where the function is decreasing. Okay. So where is the function increasing? The function is increasing wherever there is a positive sign. Right. So interval where the function is increasing. Okay. So x such that below 0 and above 2. So x such that x is less than 0, union x greater than 2, x element of real numbers. So that's where the function is increasing. Where is it decreasing? To look at the place where the function is decreasing, we again look at the place where the slope is negative. The slope is negative from 0 to 2. So that means the interval where the function is decreasing is between 0 and 2 for all x element of real numbers. Okay. So that basically gives us the interval where the function is decreasing or increasing. But the question asked us to find next, right? Question asked next is to locate using the first derivative test where there is a relative maxima and where there is a relative minimum. Now, let's see what does the first derivative test say. Okay, first derivative test. I'll explain to you guys in graphical form. According to the first derivative test, okay, if to the left of a number x0, where x0 is my critical point, to the left of x0 is negative and to the right is positive, right? A negative slope is something like this, a positive slope is something like that. Now if you put that together, that becomes something of a u. Now this means that that is a relative minimum. Okay, so this implies that is a relative minimum. Okay, then, okay, second one, if we have got a critical point x0 and to the right is positive and to the left is negative, right, so positive slope is upwards, negative slope is downwards. If you put that together, that is something like this, and that is like a hill. So that implies that that is a relative maximum. So, utilizing this, okay, this concept that we have gone through, let's see where is the relative maximum and where is the relative minimum. Okay, let's go back to our graph, to this place over here. Okay, right, so our critical point is 0 and 2. Now as you can see, to the left of 0 is positive and to the right is negative. So therefore 0 is the relative maximum, because a positive slope followed by a negative slope would result in a relative maximum. And then look at 2. To the left is negative, to the right is positive. So according to the first derivative test, that's a relative minimum. So let's put that down on pen and paper now. So relative maximum occurs at x is equal to 0. So let's find f of 0 to give you guys a coordinate. F of 0 will become 0 cubed minus 3 into 0 squared plus 1, that is equal to 1. So the relative maximum, therefore the coordinate is at 0, 1. Then let's find the relative minimum. Relative minimum occurs at x is equal to 2. Okay, so let's find what is f of 2. So we'll have 2 cubed minus 3 into 2 squared plus 1. So 2 cubed is 8. So 2 squared is 4. 4 3s 12 plus 1. So 8 minus 12 is minus 4. Minus 4 plus 1 is minus 3. So therefore the coordinate for relative minimum is 2 minus 3. That's the solution set for this particular problem. Thank you.